Okay, so we're looking at applications. We started applications last class period, and I just pulled up some questions through my math lab, and we're going to look at those and go through some of these. So right here, we're just trying to translate things in terms of words, a mathematical equation. So it's telling us that the area of a square is the square of the length of a side. So area of a square. So area, we know we can denote that by A. In this case, they did capital A, and they give us a drag down, so this isn't as hard as, hopefully. But before I even pull that. So is in the statement usually means that you're going to put the equal sign. So area A is equals the square of the length of a side. So if we let L be the length of a side, it's telling me that it's equal to the square of that. So L squared. So they might do S squared in here. It just depends. Yeah, so square is S squared. That one was too easy. So this says the force equals the product of mass and acceleration. Force equals the product. So product tells us multiplication, mass and acceleration. So we can let M be mass. What it tells us down here. M is mass and A is acceleration. So we know F is M times A. Okay, let's go to some harder ones. Maybe the total revenue derived from selling X dishwashers. So we know that X is the number that we're selling of dishwashers, is $180 per dishwasher times the number of dishwashers sold. So the revenue of selling X dishwashers is, so equals 180 times the number of dishwashers sold, which we know is X. Okay, I'm gonna go to a different. Okay. Let me snip this. Okay, so this was one tool, and I probably told you this, that I just found out maybe about 3 years ago, and it's been like a lifesaver with teaching and being able to just copy things like this and put it on like a worksheet. So I also found another tool, and you guys probably already know how to do it. But do you ever like typing an email or something, or you're typing something and you accidentally, something like erases a huge chunk of it because it accidentally gets highlighted or something, and you're like, what the heck? I just spent a half an hour typing that. Control Z. Control Z will get it all back for you. It's a miracle. So hopefully that someday remember that. Okay, so I'm going to pull this and we're going to put it on the page. And hopefully it just magically appears, and it didn't. That's because maybe I was talking too long. No, it's not. So let me just save it. copy. Okay, so we're doing interest, depending on what type of interest problem. We have simple interest, I equals PRT. That's just the interest that you get. If we are trying to figure out the amount that we owe, or because we borrowed some after a certain amount of time, or how much money we're gaining because we invested. So this amount is equal to P. So the principal, how much that you've added into the account or borrowed, all times 1 plus, well, it depends. Sometimes it's compounded more than once a year. So maybe it's compounded semi-annually, so twice a year, a monthly, or we'll even get it down to daily or continuously. But so depending on that, we're going to have it R, your interest rate, in decimal form, all over N, which is the number of times that you're going to compound it per year. And then that parentheses is all raised to the N times T. So P equals principal. Make sure R is in decimal form. Of interest rate, so percent to decimal. T is time. Usually in our case, because is years. And N is the number of times compounded per year. So bank loaned out $15,000, part at a rate of 9% per year, and the rest at a rate of 19% per year. If the interest received in 1 year, so our interest received in 1 year is a total of $2,000, how much was loaned at 9%? Okay, so maybe we can let X equal the amount that was loaned at 9%. So 9%. So if that's the case, we know that the $15,000 was total. And so I know that $15,000, right, minus how much we invested at 9%, this would have to equal then the amount invested at 19%. Okay, so it doesn't say anything about in here about being compounded multiple times a year. So we're just going to assume that it's once a year. And we know how much the interest is that we get back, or no, we know if the interest received. Okay, so we just know the interest. Okay, I needed to know that. So basically, to me, if that interest is totaled, let's just start here. If that interest is totaled to be $2,000, That's a lot of money. Okay. I know the amount after 1 year is what I started with, the $15,000 plus my interest, which is the $2,000. So I know that this is equal to $17,000. So let's just go through and put in what we have. So we have $17,000 is equal to so we got two pieces, and you know what, I really could have done this as simple interest right here, but I didn't, so I'm just going to use this formula. So I have my principal, so that's the amount I've invested in one. We said X dollars is in one, so X all times the interest, which is 9%, all times 1 plus the interest, 9%, 0.09, all over the number times a year, which is 1. And this is raised to, it was only invested for 1 year, so the first. So that's just the amount back from the one account, and then the second account. So plus, well, they've invested that 15,000 minus X at the 19%. And so that is 1 plus interest rate 19, 0.19. All raised to the first. So we have an equation here with one variable. So 17,000 equals X times, well, 1 plus 1.09, or 1 plus 0.09 is 1.09 plus, we're going to distribute in a second, but we have 15,000 in parentheses minus X in parentheses all times 1.19. There it is. So 17,000 is 1.09x plus 15,000 times 1.19, which is 17,850 minus 1.19x. Let's subtract to get the numbers without the variables to one side. So let's subtract 17,850 to both sides. And at the same time, on the other side, let's combine those like terms. Okay, well, my larger number is negative. So 17,850 minus 17,000 is 850, but the larger one was negative. So this is negative 850 equals 1.09x minus 1.19x. That would give me, so again, larger one is negative. This is going to be negative 0.1. X. And you can put the 0 there if you want. And then divide both sides by 0.1. So 850 divided by 0.1, which gives us 8,050. And so they wanted to know how much was invested at the 9% and or loaned, the bank loaned, and how much was at the 19%. So 9% was the 8,000. And if we took that from 15,000, we get that 6,500 was at the and that's not X in this case. So 6,500 at 19%. Okay, so let's go back and show that we got it right. So we said 8,500. I just love the positive feedback, don't you? You probably cringe when it says, sorry, but. Okay. Yeah, mixture problem. Let's just grab one of those. Okay. Let's grab it. So I blindly chose one. Let's see. Okay, so how much water, so I right now know what I'm going to choose my variable, must be evaporated from 36 ounces of a 8% solution to make a 9% salt solution. Okay, so we have salt, we have water, we have our solution, we have the amount of substance, whatever you're talking about. We have the percent, and we have totals. How much water should be evaporated from 36 ounces of an 8% salt solution? Okay, so we have 36 ounces of this salt solution. I'm going to just call it solution. Yeah. And the amount of it, so we just said, was 36 ounces. The percent was 8%, so 0.08. And we have this as 0.08. 8% of this is 36 ounces. So how much water? So let X equals the amount of water evaporated. Well, if that's the case, then I know that my new solution, it first had 36 ounces. Now it's evaporated X ounces. And so now my new solution is going to have 36 minus X. So let's go down here for amount of that is 36 minus X. Well, water, how much salt is in water, that salt solution? What percent of that is salt? So none of that should be salts, right? And then the total, so 0 times X. We want our new solution to be 0.09. And then the totals of our new solution would be 0.09 all times 36 minus X. Amount of solutions, okay. Okay, so this is what I believe we do. But so we're gonna have 36 all times 0.08 plus X all times 0. We want this to equal, and we're just doing this, equals 0.09 times 36 minus X. Okay, so 36 times 0.08, that's 2.88. 0 times anything is 0. That X plus, or equals, so let's distribute this. So 0.09 times 36, that gives us 3.24. And then 0.09 times X. So this is negative 0.09 X. So let's subtract 3.24. So 2.88 minus 3.24 is negative 0.36. Is equal to negative 0.09. Divide that. So X is equal to 4. And we're talking about ounces. So to me, that's telling me that 4 ounces of water would have to evaporate in order to make a 9% salt solution. Okay. So we said 4 ounces. Let me pull up another one. Okay, so before I pull up another one, I'm going to pause the video for a second. I think you guys might need some motivation. Okay, so we just watched a motivational video off of YouTube, and so hopefully that gave you some motivation to keep strong. But coming back to those word problems, question was, how do I know when I see a word problem, how to go about it, what equation to use? And like in this case, I have a grid up here. And so sometimes I do grids, and it really kind of depends on what type of problem I'm dealing with. A lot of times with my distance equals rate times times problem, and I have multiple things going on, I like to do that. And especially these mixture problems, these weren't always the easiest for me. But I think that for me, having the grid helps. For mixture problems, basically, let's see. Let's say you have, let's see, I'm trying to, basically the totals of things is the amount of a substance times the percent. And I'm trying to think of something that might become easy to you. So if I wanted 75% of $20, I would find that total amount, right, by taking the percent times the 75%, 0.75 times the $20. And that would give me the total of what 75% of that is. A lot of times with these mixture problems, we have multiple things going on. So maybe you have nuts and you have chocolate and you want to do a mixture of chocolate and nuts, and you want, a percent of this costs this and that. You tend to do the percentage times the substance, and you add it together. It gives us the percent times the amount of the new substance. So let me see if I can pull one more similar to that, and we can walk it through while we're doing that. Sometimes drawing pictures is helpful, things to do. Usually when I go through these, I always, I usually read it. I have to read a word problem multiple times. And then I go through and I kind of nitpick and pull out the information I know, and I try to think about all equations that we know about that subject and how I can use that and manipulate that to answer. So let's look at this. So we have some chemistry question. And it says, how much pure acid? So in a way, these pure acid and the one before, which the water was evaporating, is a little bit trickier than if it had just given me a percent in there. Pure acid, that tells me that's 100%. How much pure acid should be mixed with 4 gallons of 30% acid solution in order to get an 80% acid solution? And so I know I have pure acid. So this is the amount of the substance. This would be the percent of what we're looking at, and this would be our total. I know the amount, so how much pure acid should be mixed? So right there, usually a question like that tells me that's what I can let my variable represent. So let X equal the amount of pure acid. To be mixed. And so we're going to put X here. And because we're in gallons, I'm going to put gallons here. So we're in gallons, GAL. So pure acid, it's all acid. It's 100% acid. And we want to put this in decimal form. So 100% is equal to 1. So the total amount of acid that we're getting is 1 times X. And then we have what we're mixing it to. And so looking at this, how much should be mixed with 4 gallons of 30% acid solution? So we have this acid solution. It tells me that it's 4 gallons that I'm mixing it to. And it tells me it's 30% acid, so 0.30. And so if I was looking at those 4 gallons, how much of that was acid, I would multiply that 0.3 times the 4. And then we have our new solution. With our new solution, we had X gallons of the pure acid, and then we're adding, or that was what we're adding, to the 4 gallons. And so our new solution will have the 4 gallons plus the amount of pure acid we added. And we want it to be an 80% solution, so 0.8. And so of this, we have 0.8 times 4 plus X. So I'm taking my original pure acid, which is 100%, 1 times the X amount that I'm adding to plus, we have the 4 gallons, all times the 30%, 0.3. We want this to equal 80%, so 0.8 of the new amount. Well, the new amount is the 4 gallons plus the X gallons we added. So simplify, we have X plus, well, 4 times 3 is 12. So this is 1.2 is equal to, well, 4 times 8 is 32, move my decimal over 1, so 3.2. 0.8 times X, so plus 0.8X. We want constants to one side and variables to the other side. So if we subtract 1.2 on both sides, and we subtract 0.8x on both sides, well, when you're subtracting, think of this as 1.0x. So 1.0x minus 0.8x, that's 0.2x, is equal to 3.2 minus 1.2. This is 2 divided by 0.2. Well, we can get rid of that decimal by multiplying by a fancy one of 10 if you want to look at it this way. So x is 20 over 2. which reduces to 10. So we need 10 gallons of pure acid. So that 10 gallons of pure acid is going to be mixed to the 4 gallons. That's going to give us a new solution, 80% acid, and we'll have 14 gallons of that solution. Let me just make sure I got it every type. Let's do a constant rate problem. Okay, so these are types of word problems where you have one person or one machine that is doing a job, and then you have another person or another machine doing the same job, and if you work together, how long would it take us? And so ways to set this up is 1 over the time it takes somebody to do a job, plus 1 over the time it takes another person to do the same job, dot, 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 equals, hopefully that wasn't offensive to you, equals 1 over the total number of hours to do the job together. Okay, so let's do this. Okay, so we got a winery, has a vat with 2 pipes leading to it. The inlet can fill the vat in 7 hours, while the outlet can empty in 9 hours. So, how long will it take the vat if both pipes are left open? Okay, I was gonna say, how long will it do what? Fill it, but yeah, and it says fill it. Okay, so we got 2 things going on here. You have a limit, an inlet, and it can fill the vat in 7 hours. So I know that 1 over x, that's the time it takes to do the job by itself. But unfortunately, there was a pipe. My guess is it was accidentally left open, because why would we be filling in it coming out, but who knows. While the outlet pipe can empty it in 9 hours. So I know that this would be minus 1 over 9. How long will it take the vat to fill? Oh wait, sorry. I don't know why I put X there. It was 7 hours here. And this would be 1 over X. X is equal to the time to fill. Okay, so normally, usually we work together, not against, and so we put a plus here. And so let's just multiply by our LCD, 7 times 9, 63 times X. So we can get rid of our fractions by multiplying each piece by 63x. So 7 goes into 63 9 times, we have 9x, minus 9 goes into 63 7 times, and so we have minus 7x. This is equal to 63. So we have 9x minus 7x is 2x. And this is equal to 63. So we get x is equal to 31.5. We were talking about hours. So normally would have been able to fill in 7 hours, but now because of the pipe being open, it's taking that 31.5 hours to fill up. Okay, so I think we covered all the different types of word problems from this section. Let's take a break and then come back, and then we'll jump into chapter 2. So I promised you that I don't think chapter 2 is as hard as this chapter, but again, it's all review stuff. And so we might pick up the pace a little bit on this chapter. But let's go take a 12-minute break, and I'll see you back a little bit before 9:15. Okay, so we're going to look at distance and midpoint formulas. I'm going to actually derive the distance formula for you guys. And so what we need in order to derive that distance formula is the Pythagorean theorem. So that says if you have a right triangle and we have our hypotenuse, I'm going to call it C, and then the legs, those are the ones that are not the hypotenuse. Hypotenuse is always across from the 90-degree angle. It says that if we square each leg and sum that square, so a squared plus b squared, this is equal to the hypotenuse c squared. Okay, so you're going to use that a lot when you get into trig, if you haven't taken trig, but you'll also use that a lot also in calculus, especially calculus 2. So let's look at the distance formula. So knowing that, let's say we have 2 points. You want to find the distance between 2 points. And let's call them arbitrarily x sub 1, y sub 1, and x sub 2, y sub 2. So let's go and let's plot those 2 points. I'm actually going to put this. Okay, so let's say we have those 2 points right there, and we're going to plot those 2 points. Let's say this is x sub 1, and so let's say this is our point, and let's say, actually let's move it down because it really doesn't matter. So that would mean that is our y value of that point, so that's y sub 1. So let's call this x sub 2. And you put a point up here, so this would be our y value, y sub 2. And we're trying to find this distance in here. So we want to find that length of a line between those 2 points. So what we can do is we can form a right triangle with this. And so let's look at the distance between x sub 1 and x sub 2. So a horizontal line between that, and then a vertical line. And so we need to find the length. We want the length of this, and we want the length of each leg. So the horizontal and the vertical side of this triangle. So we can actually express this. So basically the base, the bottom, right here, that's this length right in here, in between my x of 1 and x of 2. I need to figure out what that distance is. Well, this is the x value, and if I take this x value, right, and I subtract off the other x value, that distance between the origin and this value is this, where the distance of x of 2 and the origin, is all the way over here, right? And so if I subtract off this x of 1 piece, that would give me the distance of this. So I can say this here is the same thing as x of 2 minus x of 1. So same kind of idea with my y values. I can figure out that length this vertical line is. Well, I know that y sub 2, if I looked at the distance from the origin up to this value, that's the length of this line. But if I subtract off this y sub 1 value, which is the distance from the origin up to here, if I subtract that off, that would just give me the length that I want. And that would be y sub 2 minus y sub 1. So let's use the Pythagorean theorem now. The Pythagorean theorem says, okay, well, let's call this, in our case, let's just call it d, because we're going to use d for the distance formula. So we know that d squared, the square root of the hypotenuse, is equal to the sum of the square of each leg. So if I look at squaring x sub 2 minus x sub 1 plus the square of the value y sub 2 minus y sub 1. Almost there. We don't want this distance squared. We would just want this distance. And so we can use the square root property. And so if I take the square root of both sides, normally I put plus or minus in front of one of those square roots, but I'm talking about distance, so I'm not going to do that. We're just going to use the positive. So the square root of d squared is equal to the square root of the difference of our x values, x2 minus x of 1, quantity squared, plus the difference of my y values, y2 minus y1, and that quantity is squared. So we basically have our distance formula. So our distance, again, is equal to the square root, the change in our x value, x of 2 minus x of 1, square that, plus, and the change in our y value, y sub 2 minus y sub 1, and square that. So to me, really, these problems seem to be a lot like plug and chug. So given 2 points, be able to find the distance. I'm just going to make this a little bit bigger, and I'm going to see if I can find some problems that might be better. Okay, so it's telling me to plot each point and form a triangle ABC. Show that the triangle is a right triangle. And then it says find the area. Okay, so we're given 3 points. Get that wide. We're given 3 points, and they are about 4, -3 is our value of A. So let's just plot that one real quick. We'll go over 4 to the right, down 3. We have point B. Point B is 4, 1. And we have point C, and C is 2, 1. Now it wants to know, show that this is a right triangle. Find the 3 points, form a right triangle. Okay, well, if it's a right triangle, then we know the Pythagorean theorem has to hold. And so we're going to show Pythagorean theorem holds. Okay, so I need to find the distance between some points. And so because they're called C and B here, let's call this line CB. And let's find the length of that. So I have 2 points. I have 2, 1. This is equal to. And I have 4, 1. Okay, so it's x of 2 minus x of 1. So if I look at this point, right, my x value is 4. So I have 4 minus my x value of the other one, which was 2, plus my y value, so 1 minus 1. So this is equal to the square root of 2 squared, which is 4, plus 1 minus 1 squared is 0, squared is 0. Square root of 4 is 2. So we know that this length in here is 2. Let's find the length between B and A. The length BA, this is equal to the square root, the difference of our x values, square it, and then sum the difference of our y values, and then square it. And so B and A, so we use B first, and it really doesn't matter because we're squaring it. We have 4 minus the x value here, which is 4. And then our y value, we have 1 minus -3. 1 minus 4 and 1 minus -3. So this is equal to the square root of 4 minus 4 squared is 0 squared, which is 0, plus 1 minus a negative 3, well, minus a negative is plus, so 1 plus 3 is 4. 4 squared, 16, and the square root of 16, or the square root of 4 squared is 4. I could see these are horizontal lines and vertical lines that I could actually count over and figure that out. But our formula also works. And then the last one we want to look at, and this is the most important part, this is our hypotenuse. We want to look at CA, that length. So C and A, I would do 4 minus 2, quantity squared, negative 3 minus 1, quantity squared. Four minus 2 squared is 2 squared, plus negative 3 minus 1, which is negative 4. I'm going to square that. 2 squared is 4, plus negative 4 squared is 16. This gives me the square root of 20. Normally I would rewrite this, but I'm going to use that square root of 20 over here. So we need to show that this holds true. So we're showing that if we squared the length of a line CB and summed it to the length of a line of BA, we just found, and squared this, this must equal CA, hypotenuse. Okay, so CB, this is 2 squared plus BA, which is 4 squared. Does this really equal the root 20 squared? If it does, then we showed that it is a right triangle. So we have 2 squared is 2, 2 squared is 4, 4 squared is 16, is equal to square root of 20 squared, which is 20. 4 plus 16 is 20, and 20 equals 20. So we showed that that right there was a right triangle. And then the next part in there was asking that you showed or found the area. We know the area is equal to 1/2 times base times height. And we already did all that work up here. We have 1/2 times our base. We have is 2, all times our height, which is 4. Well, 1/2 times 2 is 1 times 4 is 4. I don't know what the units are, but just make sure if you have units, you put that unit squared. Okay, so distance formula, and then the last thing in this section was the midpoint formula. So I think of it as we're trying to find a midpoint between two lines. You have two lines. Basically, if we take the average of our x values and we take the average of the y values, that's going to be the halfway point between those two x values. And so the midpoint formula If you have 2 points, again, let's just arbitrarily call them x sub 1, y sub 1, and x sub 2, y sub 2. Midpoint is equal to get the x value of that point, again, you're going to take the average of those x values. So to take an average of something, you would add them together and divide by that number. So in this case, x sub 1 plus x sub 2 divided by 2. We want the average halfway of the y value point, so y sub 1 plus y sub 2 all over 2. Find the midpoint. Of -4, -3, and 2, 2. Just to give a kind of idea, I'm going to graph it. So go over -4, go down 3, and 2, 2. I want to find halfway point on this line. And so by this formula, it tells me to sum my x values. So summing my x values, I have -4 plus 2. And then it tells me to divide that by 2. And then it tells me to look at my y values. So we're going to sum my y values. We have -3 plus 2 and divide that by 2. So simplify the numerator and then divide. So our x value, -4 plus 2 is -2, -2 over 2. And then -3 plus 2, that's -1 all over 2. So this says -1, -1/2. So if we go down here and we look at where that is, there's -1 and -1/2. So notice that that's falling on the line, and it looks like it's the halfway point. So that is 2.1. And I wanted to start on 2.2. I might just stop that video and start a new one.